AI, machine learning, deep learning, reinforcement learning, man, it feels like a new buzzword drops every single week, right? It can get pretty confusing, but understanding the difference is actually key. Today, we're going to cut through all that noise and really demystify one of the most powerful and, frankly, fascinating areas of AI, reinforcement learning. By the end of this, you'll know exactly what it is, how it works, and why it's already shaping our world in ways you might not even realize. Okay, let's dive in.
So here's our game plan. First, we'll sort out that confusing AI family tree. Then we'll look at the 3 main ways machines learn, which will really highlight what makes our topic so unique. After that, we're going to zoom right in on its core idea, learning by pure trial and error. And then the fun part. We'll see some incredible real-world examples in action. We'll wrap up by tackling a really crucial question that this technology forces all of us to think about. All right, first things first, let's get our bearings. It is so easy to use terms like AI and machine learning interchangeably, but they actually represent different layers of a much bigger picture. The best way to think about it is that we're kind of building a pyramid of knowledge, starting with the widest, most fundamental block at the base. At the very, very top, the biggest concept, we have artificial intelligence, or AI. I want you to think of this as the giant umbrella. It's the entire field, the grand vision of creating machines that can think, learn, and solve problems kind of like we do. It's the broadest possible term, and it covers everything else we're about to talk about. So how does this all fit together? Honestly, the best analogy I've ever heard is to think of it like a set of Russian nesting dolls. Artificial intelligence is that biggest, outermost doll. You open it up, and inside you find machine learning. That's a specific way to achieve AI. And then you open that doll, and one of the most important pieces inside is reinforcement learning. So AI is the big dream, machine learning is the powerful engine, and reinforcement learning is one of the coolest tools in that engine's toolkit. Okay, so keeping that nesting doll idea in mind, let's look a little closer at that middle doll, machine learning. See, it's really important to get that machines don't just learn in one way. There are a few different approaches, and understanding them is what makes it so clear why reinforcement learning is such a big deal. Broadly, there are 3 main styles. First, you've got supervised learning. This is like studying for a test when you have the answer key. You feed the machine tons of labeled examples, like this is a picture of a cat, this is not a cat, and it learns to map the right inputs to the right outputs. Then there's unsupervised learning. Here you just dump a mountain of data on the machine with no labels at all and tell it, go find interesting patterns. And then we get to reinforcement learning. This one's different. Forget answer keys, forget hidden patterns. This is all about learning from feedback. The pet training analogy is perfect. The goal isn't just to be right, it's about figuring out a winning strategy over time to get the most treats. And that whole idea of training a pet is the perfect way to get into our main topic. It's this concept of learning from consequences, not from a set of instructions, that makes reinforcement learning so revolutionary. So let's zoom in on how this whole trial and error thing actually works under the hood. Okay, the formal definition here sounds a little dense. I get it. But let's just pull out the keywords. You have an agent, that's our learner, our little digital puppy. It takes actions in an environment, that's its world, and it does all this to get the biggest possible reward. It's not about being right or wrong on any single move, it's about playing the long game to get the most points or treats, or whatever that reward might be, over time. So it all breaks down into this really simple but incredibly powerful feedback loop. First, the agent tries something, it takes an action. Second, the environment changes and gives back some feedback, a reward for a good move or a penalty for a bad one. And third, based on that feedback, the agent updates its internal strategy, its rulebook really, for what to do next time. Now here's the clever part. It's always facing this dilemma. Should it exploit what it already knows works to get a guaranteed reward? Or should it explore and try something totally new that might lead to an even bigger payoff down the road? It repeats this loop millions, even billions of times, constantly balancing those two things and getting smarter and smarter through pure experience. Okay, that's the theory. A system that can literally teach itself how to master complex tasks without being programmed step by step, which is kind of mind-blowing when you think about it. But the obvious next question is, so what? What do we actually do with it? Where is this changing the game right now? And this is where it gets really exciting. Because reinforcement learning is not just some concept in a research lab. It's already out there, optimizing these massive, complex systems in the real world. Let's start with a number that it's just incredible. 40%. That is the reduction in energy spending that DeepMind's AI achieved in Google's data centers. Think about that. A reinforcement learning agent learned how to manage the cooling systems more efficiently than any team of human experts ever could. How? Just by trying things out, taking actions, and measuring the reward. In this case, lower energy consumption. It wasn't following human rules. It discovered its own, better strategy. A massive real-world impact. This power of self-learning is just a perfect fit for complex automation, especially things that move. It's a huge piece of the puzzle for autonomous driving, helping cars plan their path and learn tricky maneuvers. For instance, and this is an amazing example, the startup Wave.ai used deep reinforcement learning to teach a car how to follow a lane from scratch in a single day, a task that would take a human programmer countless lines of code to even attempt. And this same logic of optimizing complex systems, it works in totally digital worlds too, like finance and engineering. In the chaos of automated stock trading, an RL agent can learn its own policy for when to buy, sell, or hold, all with one goal: maximize the profit. Meanwhile, tech giants like Facebook use it to do everything from personalizing your newsfeed to optimizing video streaming quality on the fly, making sure your video plays smoothly. The versatility is just mind-boggling. It's even making its way into language and healthcare. In natural language processing, it's making chatbots better by teaching them how to have more useful, coherent conversations. And in healthcare, this is amazing. It's being used to help figure out the best long-term treatment plans for people with chronic diseases. The agent can help map out a sequence of treatments over time to maximize the reward, which in this case is the patient's long-term health. That's powerful stuff. So we've seen the what, the how, and the where. Now let's just pull back for a moment and really think about the big picture here. What does this all mean? If you take away just one thing from all of this, please let it be this. Reinforcement learning creates goal-seeking agents. You don't give them the answers. You just give them a goal in the form of a reward, and they figure out the most effective way to get there by learning from pure experience. It is a fundamentally different way of building intelligence systems. And that brings us to our final and I think most critical thought. This technology is incredibly powerful. It will optimize for whatever reward we give it, relentlessly and effectively. So the most important question we have to ask ourselves isn't really about the technology, it's about us. We are the ones defining success for these systems. So what goals do we want to set? What behaviors do we want to reward? Because in the end, the future these systems build will be a direct reflection of the values we program into them. What will we choose?